Hi guys, in this tutorial we're going to learn how to use TyFlow to generate an effect similar to this one we're seeing. It's quite simple. Let's start. Start with a box. Apply a turbo smooth. And let's delete half of it. Okay. Then cap the hole so we can see here there is a hole on the bottom. We cap it and we select the resulting polygon and we extrude it by 5. Since this thing it was 10 units wide, extending it by 5 and then keeping on extruding it until it's 100 units tall. Okay, so this should be 100. Let's delete the polygon. We don't need it anymore. And I'm gonna use solvent script pivot placer to place the pivot at the bottom of it. If you don't use the solvent script, you're missing out. And now let's bring it to 0, 0, 0. Okay, so let's create a spline out of it. We're gonna select some edges. Okay, and let's create a shape out of it and call it okay. Let's keep things tidy. So this one we're gonna name it Tendril. And we're gonna align this by on the X and Y using the center. So right now it's in the middle of our tendril. Okay. Let's create a TyFlow. Let's change its color to like nice blue. And we can use birth spline to give birth to our splines and using knots and the display. Okay, so let's see it on the side. There's a particle for each like loop of it. Okay, so let's move on. I'm gonna create a cylinder. Radius 5 and height slightly less than 5. Let's see, this one should be okay. And this is like cylinder bone, and we're gonna use it as a shape. Since the last updates of TyFlow, we have tabs here to move more easily between the kind of operators, and it's really easy now to because there were so many. Tyson is too efficient. He added too many operators, And now it's easier to just use tab and find the ones you need. So what we're going to do is use the cylinder we created as a reference node and turn on geometry. Back to shape, we make sure that we have all the pivots centered. And let's see what's going on. Yes, that's okay. We can even a bit less, maybe. 4 is okay. So they get centered to the knots that we've seen before. Okay. And now we can try our Physx skinning. It's really easy. So we add a Physx shape, and we leave the default settings. What we want to do here is using Physx bind in a joint mode. Disable swing settings and twist. We don't need them for now. And let's use, since those are siblings because they were born on a spline, we can actually visualize it. Let's use a display data operator, and as we can see, they were born in a specific order: 1, 2, 3, 4, 5. So we can easily use the siblings method in Physx bind and disable breaking. Oops. Okay, and show the connections and endpoints. Okay, so what we want to do also is, right now if we play it, nothing happens. I mean, gravity is acting, but it's just wobbling a bit. But what we want to do actually is hit it with a ball, like we were seeing in the animation, like this. So what we need to do is put the last one stick, let the bottom one stick on place, stay in place. So what we can do is create a dummy and align it to the tendril pivot. Okay, and we don't need this. And do an object test. Picking the dummy. And if the distance is less than some value, for example, let's say 6, even less, maybe 5, 4, I don't know. We can switch the Physx shape to kinematic. So it's still gonna collide, it's still gonna do everything, it's just not gonna move, not gonna be affected by gravity, for example. And now for our collision test. Let's hide the tendril for now. And for our collision test, we can create a geosphere and animate it. And generate an object, a particle, a birth object, using this object as particle. And inherit every movement, like position, rotation, scale. We just need position here, but let's do everything. And then let's make it a Physx shape and make it kinematic. Nice. Now this is working, but this is a bit too wobbly. So what we can do to slow it down, like in the video, I keep on closing it, sorry for this. So you see the wobble is really limited. There is a lot of damping, and the easiest way, in my opinion, is just to add the slow operator. Let's try 15. Yeah, this is good. Even 25 maybe. Nice. Okay, so this is what we want, and this was just for testing the animation on just one tendril. But what we need to do now is to create an actor, and the easiest way, the right way to do this is just add the tyParticle skin it with our particles in TyFlow. Let's leave the default settings and isolate it. Yep, looks good. So now we can create a tyActor. And align it to our tendril in at the pivot. This is mandatory, or the tyActor will look offset from our object. Okay, so what we can do here is hide this. We leave this on, or it's not going to work, but we can hide it and create a new TyFlow. Let's create a plane and call it surface gen. Okay, so this should work, and we use another birth object, birth surface, and set a vertex already, and then we apply an actor operator, and we pick the actor we created. Sorry, I didn't pick the tendril. Okay, there we are. Nice. So what we can do here is let's hide the skin mesh for a second, and we can see that creating the tyActor means also we bring with us the particles that we use to skin the object. So if we turn the display to geometry, we can see that we have our cylinders. We don't have though all the physics shapes and bindings. We have to recreate them. And another thing I want to do here is just use a polyselect to select all the vertices but the ones on the outside, and see, I selected only the inside ones, and here we just use select the vertices, because if you want to replicate the original effect, I did it like with a bit of border. This is just after you skin and after you create your simulation, it's just a matter of modeling and tyParticle skin using the whole particles. But the main engine of the animation is this. So what we can do here is we create Physx shape again, and the Physx bind. Now we cannot use, like we did before, we cannot use the siblings anymore, because if we check the data, we can see the ID is not in order anymore. So this is not a problem, because we just set it to join, disable this, and show the connections, and we just use the proximity bind, just 2 max binds. So there is one for okay, let's say this particle needs some binding, it's 1 to the top one and 1 to the bottom one, and so on. And the distance is like 6, But we can see there is a problem here because they're connecting between them. And this is not something that we want, but luckily the particles, they are still considered siblings. So we just do bind siblings and they bind between just the vertical ones, not between them. Okay, so this is almost done. Let's disable bind breaking, and again we need to make the bottom one stick on the ground. So what we can do here is a surface test. Let's pick our generator as a test. Less than 6 should be okay. And then we switch those to kinematic. That's too much. Oops, sorry. We also turn the timing to uneven entry, or once we hit the tendrils, if some particles get close to the ground, they will switch, but we want them to switch just at birth. So now let's lower the test to 3. Okay, so those ones are still bound and they still can collide, but they won't be affected by gravity or whatnot, and they will stick to the ground. So let's create a collider to test this. This one is, yeah, let's use the existing one. Why not? Maybe more radius, and let's delete the final frame. Let's disable the animation. Auto key on. Linear is okay. Maybe it's a bit too fast. Okay, this should work. And again, we do a birth object, pick our geosphere, and inherit its position, hide it. Okay, so this is a particle now, and we can just Physx shape and make it kinematic, so it's gonna follow the original animation. It's not gonna be affected by gravity or other forces, but it's gonna collide with the other Physx shapes. So let's see what's going on. Let's disable the edge face, and we can hide the original TyFlow and the tendril and the actor as well. Yeah, let's keep things a bit tidy. Sorry, I had to reopen the file. So we were seeing the effect of our simulation. Yeah, it's looking good already. If you need to improve the animation because something goes wrong or well, let's see how it looks with the actor skin mesh turned on. I don't see any mistakes. Yep, it's working. Actually, this flow, from now on, this is just a matter of modeling, because you can like generate a mesh out of it with snapshot, for example, and then model it and then tie particle skin to the particles. But this is beyond our scope. What we can do here is something. Let's add some another operator here, like the position, the object bind operator. So we're gonna bind the stuck particle, the ones that get stuck to the ground. We're gonna bind them to those ones. We're gonna bind them to the surface, because if we have a look at the animation, this is the movement they do before colliding with the sphere. And if we want this, it's really easy. So let's turn off the flow for 1 second. We object bind them to the surface. Then let's say that surface is animated like this. So auto key and like this, and then the sphere, we stagger its animation, we move it like this. Okay, we can turn on the flow again and see how it follows the plane animation, and then it collides with the sphere, like in the original animation I showed you. Nice. A variation of this, let's select the plane. Okay, let's delete the animation just for the sake of the variation I want to show you. Let's create a box. Okay, in our TyFlow we turn off this one and we create again a birth object. We pick the box. Now we can hide the original one, and let's create a point. Okay, and let's add find target operator, and we want to find the point that we just created. Let's add a Physx shape operator to our box. Let's put the box slightly above the ground, so 1 centimeter above the Physx ground. Let's see what happens. Turn off this one. Okay, so what we want to do here is just wrangle the settings until okay. Let's increase a lot the friction, so it's gonna tumble. Nice. And maybe let's make it start here. Okay, let's turn on our tendril simulation again, see what happens. Okay, this is not, we can see this feels like it's too light to bend our tendrils. So the easiest way to fix this, it's just increase its mass. Oops, sorry. Here we are. Let's try 100. Not yet. So 1000. And now it's working. Yep, nice. So this is a variation. I just wanted to show the difference in applying a different mass on the physics objects. And we can maybe raise the friction even a bit more. Nice. Okay, so let's turn off the display geometry and turn on the actor skinning. Yeah, looks good. So what we can do here now is just, again, make a snapshot of this. For example, just 2 snapshot, and we're going to obtain a mesh. And what we can do is simply model it as like the original video I showed you before. So with the tendrils bound to a rectangular basis, and this is just a modeling thing. I'm not going to go through this, but then you can turbo smooth it. Let's hide the generated skin mesh and the Physx bindings. Okay, and before turbo smoothing, we can do a type particle skin again. Pick our TyFlow. Oh, you can see some problems there. So to avoid this problem, let's try to lower the distance, like 3. Yep, looks good. From now on, it's just a matter of if you want to make the loop, you just point cache it and then loop the point cache, but this is beyond the scope of this tutorial. I hope you enjoyed it. I hope you learned something, and let's catch to the next time.